Okay, so continuing on, we've got the substitution rule for definite integrals. And so you can kind of take in this. An important thing to remember is this g of b, g of a. We're going to use it in one of the problems coming up. But for the first example, we're going to do exactly the same thing, only we're going to plug in numbers. And so let's get to it. So we've got the integral from 0 to 4 of 2x plus 1. What I want you to do is try to kind of predict what I'm going to do. Maybe pause the video and try to guess what I'm going to choose for u. And so I would do that now. So u is going to equal 2x plus 1. So that means du is going to equal 2 dx. So we're going to divide by 2. And now we've got 1/2 du is equal to dx. Okay. And so we're going to call u, I'm going to rewrite this. This is 0 to 4. U to the 1/2, and we said du, or dx is 1/2 du. Okay, so I'm going to factor out the 1/2. 0 to 4, u to the 1/2 du. Okay, now we're going to integrate. We have 1/2 integral from, actually we're going to integrate, so this is going to be u to the 3/2 over 3/2 from 0 to 4. Okay, and so this simplifies to 1/2 u to the 3/2, 2 over 3, 4 to 0. Now I'm going to multiply this 2 back in here, so this is going to be 2u over 2 times 3, 3/2, 4 to 0, cancels, so now we have, this is just u to the 3/2 over 3 from 4 to 0. Okay, u was 2x plus 1, it looks like, so 2x plus 1 to the 3/2 over 3 from 4 to 0. Okay, so we're just going to plug this in. So we've got 2 times 4 plus 1 over 3, 3/2 minus 2 times 0. Yeah, there we go. Plus 1 to the 3/2 over 3. Okay, so I've just done the subtraction rule, plugged in the 4 for the first one, 0 for the second one. This is going to be 9 to the 3/2 over 3 minus 1. This is 0, this is 1, so 1 to the 3/2 over 3. And then this is going to be the square root of 9 to the 3rd over 3 minus 1/3. And so this is going to be 3 cubed, which is 27 over 3 minus 1/3, which is equal to 26 over 3. That's your final answer. Okay, so that's that one. Now it's gonna be the next one. I think you can do most of the problem, but we're gonna end up changing the limits on this, and you'll see how in just a second. So we've got the integral from 2 to 1 dx over 3 minus 5x squared. Oops, 5x squared that way. Okay, we have dx on there, sorry. Okay, so once again, maybe pick what u should be if you want to pause the video. So I'm just going to choose 3 minus 5x. That means du is going to equal negative 5 dx. And so we get dx is equal to negative du over 5. Now, since we're going to switch this to u, let's figure out the new limits. So we've got u is equal to 3 times negative 5 times 2. That's the first limit, the upper bound. So this is going to be u equals 3 minus 10, which is equal to negative 7. And then if we use 1, we have u equals 3 minus 5 times 1. And this is 3 minus 5, which is equal to negative 2. Okay, so I hope I haven't tricked anybody or done anything too crazy for anybody. So we've got our new limits. Negative 7 and negative 2. And we're just going to replace them how they go on there. So we've got the integral from negative 2 to negative 7. Okay, and then dx we said is negative du over 5, and then u to the second on the bottom. Okay, so let's factor out the negative 1/5. We've got negative 1/5, the integral from negative 2 to negative 7, du over u squared. Okay, and then we're going to rewrite this negative 1/5, the integral from negative 2 to negative 7, u to the negative 7 du, which is negative 1/5 times u to the negative 1 over negative 1, from negative 2 to negative 7. Okay, so I'm going to multiply this back in right now. This is going to equal 1 over 5u, negative 7 to negative 2. And so this is going to be negative 1 over 35 minus negative 1 over 10. Okay, and then from here, how can we do this? 70, so this is going to be negative 2 over 70 plus 7 over 70, which is 5 over 70, which I believe is 1 over 14. And that is our solution. Now, we didn't necessarily actually have to change these limits if we didn't want to. It turns out that if we had just done this the same way we've been doing it, we would have still gotten that same answer. Oops, I didn't mean to click that. So just keep that in mind. If you forget to change the limits, that's fine too, because that rule said that you can do it either way. So let's just look at it again. Notice that we have from A to B here. We have from G of A to G of B, and so that's essentially or effectively what we did. We did the second one by G of B and G of A, and we did the first one by B of A, or I'm sorry, by B and A. And so hopefully that's kind of a neat trick that you guys can keep in mind. I guess I kind of tricked you a little. I said that, oh, we have to do it this way. We didn't have to do it that way. I just chose to do it that way to show you that you can do it either way, and sometimes it might be nicer to do the other way, the G of A way, than to use the A and B. So suppose f is continuous on the closed interval negative A to B, or negative A to positive A. If f is even, then you kind of have this rule where you just double it. Okay, and then once again, if you go from A to B and it's odd, then it's going to equal 0 because they're going to cancel each other out. It's going to subtract off what you added on if they're symmetric. So We've got them being continuous again. I guess I gotta prove this, so what I'm gonna do is I'll stop the video here. I think my dog might start barking pretty soon, and then we will go and make another video. So thank you guys for watching.